Hello there and welcome to Lower 6 Maths. This is the Applied Practice Paper E. Here we're working on question 8. A particle P is travelling in a straight line. At a time t seconds, the displacement of P from a point O and the line is s meters. At time t seconds, the acceleration of P is 12t minus 4. So A equals 12t minus 4. When t equals 1, s equals 2, and when t equals 3, s equals 30. Find the displacement when t equals 2. Okay, what we're going to have to do then is we're going to have to go through some integration here. So when we first integrate acceleration, we're going to get ourselves velocity. However, that's not too much use to us yet. We're going to have to integrate it again to get ourselves back to displacement. So we're going to need to do some double integration here to get from acceleration back to displacement. So the first thing we're going to need to do then is do v equals the integral of 12t minus 4 dt. And this is going to be, so we increase the power by 1 and divide by that new power. So t now becomes squared and we divide by 2, so that's going to be a 6. And the minus 4 here, that's just going to become minus 4t. And then remember we need that plus c at the end of every integration. Now we're going to integrate this again, and we're going to use that c there as just a value of a number. We don't know what that number is yet. We're going to have to do it when we get back down to displacement. So the answer to this is, so we increase the power by 1, so it's going to be t cubed divided by 3 and you get a 2. T increase the power by 1 and you get t squared. 4 divided by 2 is 2. Plus ct, so we treat t here, so the value c, as just a number, like the number 7. So you'd integrate 7 to 7t, just like you do c to ct. And we've already used c once, so I'll probably use a different constant at the end of this integration, so plus d, say. Right, now what we're going to do is we're going to insert these values here, and it looks like we're going to get simultaneous equations. We need to work out c and d, and we've given two values to plug in. So yeah, simultaneous equations. So in the first case here, we're going to have s equals 2 equals 2 times 1 cubed, that's 2, minus 2 times 1 squared, that's 2, plus c times 1, that's c, add d. So our first equation here is c plus d equals 2. And in the second substitution here, we're going to get s is 30 equals, t is 3 this time, so 3 cubed, that's 27. Double that and you get 54. Plugging in 3 here, you get a 9. And take away 2 times that, that's take away 18. In this next one here, it's going to be plus 3c, because t is the value 3, plus d. So in this case here, when we simplify this and take it onto the other side, we're going to get 36 here, take away the 36, so it's going to be 3c plus d equals minus 6. Okay, so we've got the same values of d here, so if we do equation 2 take away equation 1, we're going to get 2c equals minus 8. So in this case here, c is minus 4. And effectively then, d is the value 6. So the formula for our displacement is going to be 2t cubed minus 2t squared minus 4t plus 6. Okay, and the final part of this question is find the displacement when t is 2. So s equals 16 minus 8 minus another 8 plus 6. Those two will cancel there, so s equals 6 meters. Okay, great. So that's 8 marks for that question.